What's up guys, welcome back to the channel. In this video tutorial we are going to discuss how to implement a tree data structure, and also we will discuss the coding part of this. Means I will explain one line by line of code how we are implementing the tree data structure and what are the various functions and prerequisites which are required. So how dynamically node is created and more other stuff I will basically clear in this video. So make sure you have watched our previous video in which we have cleared the basic concepts regarding the tree data structures, and we have discussed about the introduction to the tree data structures. So if you have not watched that video, so please I will request you to watch that video and then come to this video. So let us see. First of all, let me discuss how the tree data structure look like. So I explained that this is a node, clear. So I am discussing about the binary trees basically. So this is a connected node which is the left children of this, and this is also a connected node which is the right children of this. Similarly, let's take another two children of this particular node. This is the left children of the above node and this is the right children of the above node, and similarly I am taking here only one children which is the right children, clear. So I have also discussed what is a binary tree. Binary tree is basically a tree in which every node having at most two children. So it doesn't mean that it is necessary to every node having two children. Every node having can maximum two children. So it is also possible that every node doesn't having children, but it is not possible that any node having more than two children. So that is known as a binary tree. So these circles are basically represented by a nodes. This is a node, this is also a node, this is also, and this is also, this is also, and this is also. So let's, before moving to the coding part of how to implement a tree data structure, let me explain the structure of a node, how this circular part actually look like. So I'm assuming that you have also done the structure in a C++ or C, structures in C or C++, structures. If you have not learned about the structures, so I request you to please learn about this. And also you have learned about the pointers. So if you know these two concepts, it is very easy for you to basically understand the implementation of a tree data structures. So structure, pointers, these concepts should be in your mind. So basically the circles we are drawing here is nothing but this circle. See, the circular way in which I am representing a node, this is nothing but this is a user defined data type, that is a struct. So I will create a struct node. So how it is look like, if you basically practically how it is look like will be, it will look like this. So it having basically like this one, it is like a box which having a three fields. Okay, so it having a three fields. The central field, let us assume central field is the data. So I am writing only a D here. This is the data field. I can write whole of this thing. So this is the data, clear. Now if you carefully observe, every node can have a left children, like this node having a left children, may or may not be, but maybe every node having a left or a right children. So every node may having a right children also. So if you carefully see, there are three fields totally. One is the data field in which I will store a data like this, and in the another is the left and right field. So it is the left field here and here is the right field. So let me write it right field. Okay, so what is the meaning of a left and right? So in the previous video I have also explained that the nodes is nothing but it is a user defined data type, that is a structure, and it having a three fields. One is the data field. In the data field I will store the data, and in the left field I am storing the address of the left children of the current node. In the right field I will be storing the address of the right children of the current node. So I hope you understand the concept. So suppose if I have created this node, clear. So if I have created this node, so I am storing the data 1 here. So let us see, suppose this node having a left children, any left children. So let us suppose it having some left children like this. Let's suppose the left children data is 2, and the address of this left children, see, very important, address of this left children, let's suppose 100. So the address of this left children will be stored in the left part of this particular one. Okay, so the highlighted, the thing I am highlighting is the current node. So this is my current node. Okay, so if there is a left children to the current node, then the address of that particular one will be stored in the left field. Similarly, if there is any right node, let us suppose I am assuming there is no right children of this current node, this current highlighted node. So it means it doesn't having any right children. So in the right field of this, there will be a null. So here I will store a null. Here I will store a null. So I hope you understand the concept of this tree data structure. So now the question arises, how basically we are implementing it. So basically what I will do is, I will dynamically create a node, and then I ask user, do you want this node to have a left children? If user said yes, I want to have a left children, or we can say that I will simply create a node first of all. Clear. This node, suppose this node is created, I have assigned some data to it. Then I will ask the user, enter the left children to your node with data 1. So user will enter the data, and I will create another node which will be the left children of the current node, and it will storing the another data. And again I will ask the user, enter the left children of 2. So again, if user wants to create a left children, let's suppose user wants to create a left children of 2 as a 3. So I will ask user, enter the data, and it will put a 3. He will put a 3. And after again I will ask user, do you want to enter the left children of 3. So let us suppose user doesn't want to having any more left children. So we will be taking a -1 as a stopping condition. So if user enters -1, it means that user doesn't want 3 to have a left children. So we will assign null in its left field. And then what about the right field? We will simply ask, enter the right children of 3. So let us suppose user also doesn't want to have a right children of 3. So I will also assign here null. Clear? So then we go back to 2. And as you can see, the left children of 2 is completed. I will ask the user, enter the right children of 2. So let us suppose user have entered 4. Then I will ask the user to enter the left children of 4. So let us suppose user doesn't want to have, so I will simply assign null here. And similarly I will ask now, enter the right children of 4. So let us suppose user doesn't want to have a right children also. So here we will be storing a null. And after that I goes to 2. So as you can see, the left and right children of the 2 has been taken. So I will go to the 1. As you can see, for the 1, the left children is a 2. So left children is completed. Now we will ask user, enter the right children of 1. So if you carefully observing, recursively we are continuously asking for each and every dynamically created node to the user. For each and every dynamically created node to the user, I am asking what is its left children and what is its right children. Similarly, when a new left and new right is created for that particular one, for each and every dynamically created node, I am asking user that what is the left children and what is the right children. And whenever the user enters the left children, I will simply create that node as a left children of the parent node. So let me clearly represent it again. So let us suppose I am basically representing how basically my this create function will works. I am also discussing the code. So also the prerequisite for this video is you need to understand the recursion also, because we are recursively creating a basically a binary tree. So first of all, I will ask the user, enter the node data. So let us suppose user have created the first node as a 1. So one more important thing is this will be pointed by a root. Okay, the root is a pointer, not a node, but just a pointer which will point to the first node. So I will ask the user, enter the first node data. So user will enter the -1. Then I will ask, enter the, for each and every node I will ask the left children as well as the right children. So I will ask what will be the left children of 1. So let us suppose user have entered 2, and then for 2 I will ask what is the left children of 2. Let us suppose user entered 3, and then for 3 I will ask what is the left children of 3. So let us suppose if I doesn't want it to have a left children, so I will simply assign a -1. It means in the left field of 3 null will be assigned, and because its left part is completed. So now I will ask the user what is the right children of 3. So let us suppose user doesn't want to having the right children of 3. So again I will type a -1, and the null will be stored in the right field of a 3. So for this particular one we have taken a left and right children, but for this 2 we have only taken a left children. We have doesn't ask the user until now what is the right children of 2. So I will ask the user, enter the right children of 2. So let us suppose user wants to have a 4 as the right children. So I have entered 4 here, and then for the 4 I will ask what is the left children. Let us suppose user doesn't want to have, so I will assign null here, and then I ask what is the right children of 4. Let us suppose user doesn't want 4 to have a right children. So I will take a special case of -1. Whenever the entered data is a -1, it means that user doesn't want to have a right or a left children of the current node. So I will store a null here. Clear? So similarly, for each and every node I am asking for a left children as well as a right children. So this is the concept behind a function. So let's move to the coding part, and then we will dry run the code, and I will give you surety that you will understand how we will create a binary tree recursively. So let's move to the coding part. So guys, let us see the coding part of this. So first of all, if you carefully observe this thing, I have basically defined a structure here. So it is nothing but a node. If you carefully see, I have taken struct node. So what does it means that I have defined a structure to my node, that my node will containing a 3 fields. What are these 3 fields? Let us see. So see, here I have defined data, integer data. In this field I will be storing a data. Anything my data will be stored in this field, and then I have defined a left field and a right field. So in the left field I am storing the address. So because of that thing, I have taken it as a pointer. So if you carefully see, I have taken a left as a pointer and right as a pointer. So I have taken left and right as a pointer because in the left field will be storing a address of the left node, and the right field will be storing a address of the right node. So address will be stored in the pointer variables. And the another thing is, why I have taken a struct node here? Because if you have learned about the pointers, whenever we are storing the address of any variable, the type of the variable will be the type of the pointer. Means the type of the variable whose address we are storing will be the type of our pointer. So because the left pointer will be storing the address of a next left node, so basically we are storing the address of a node. So the type of a pointer is also a type of a node. So it is nothing but a user defined data type, like int, float, char are the primitive or inbuilt data types. Similarly, we have defined our own data type like a node. So basically we having a 3 fields here. What are these 3 fields are? We having a basically a data field in which we are storing a data, and left field in which we will storing a address of our left node, and a right field in which we are storing a address of our right node. So I hope you understand the basically the concept of a node structure of a node. I hope you understand this. So let's move to the next part. So in the main function, first of all, what I have created, as I told you, whenever we create a tree, let us suppose I am creating a tree here, like this particular one. Let's suppose, let me create it clearly. So let us suppose I am creating a tree in a rough like this. Only 3 nodes are there. So the first node will be pointed by the root. So first node will be pointed by the root. So root will point to my first node. Clear? So this is the concept. So here I have taken a root pointer of node type. If you carefully see, node type means this root pointer will contain the address of the first node. So obviously its type will be like of a type of a root. So I have taken a root pointer here, and then initially root is equals to null, because initially when I have created any tree or any node is not inserted in my binary tree, there is no node is present in my binary tree and root is pointing to the null. And then I have created a create function here, which is the main thing. So what is the working of this create function? Basically this create function, when called, it will dynamically this create function is returning a pointer to the node. Clear? Means it is returning a pointer to the node. Basically after the creation of a tree, it will return the address of the first node or the root node, I can say. Clear? So how it works, let us see. First of all, I have called the create function. So it is a recursive function, I will explain. So in the first recursive call, let us suppose I have created an integer variable x. Clear? In the first recursive call. So let's say this is my first recursive call of create function. I am writing here C. So in the create function, what is asking me? First of all, it have created basically a temporary pointer named as a new node. So what I have done here, I have dynamically created a node in which I will store the address, in which I will store the data. Means I am creating a node here. I am dynamically allocating a memory. So in a C, we can use a malloc function or a calloc function, but in case of a C++, we are using a new operator. So with the help of this new operator, we are simply creating a node dynamically after this function is called. So after this function is called, I will ask the user, enter the data, and in the bracket I have asked enter -1 if you don't want to create a node. What does it means? I have said in the previous session that if the user enters -1, it means that user doesn't want the current node to have any left or a right children. So in that case, we will simply return a null if you carefully observe. So I will simply ask the user, I have dynamically created a node. So let me create a node here. So I have dynamically created a node here, and I ask the user, enter the data of this node. So let us suppose I have entered 1. So I will store this 1. Then I will check if x is equals to -1, it means user doesn't want to create any node. So I will simply return a null. Clear? And then in the new node that is to this node, to data field, I will assign an x, that is a 1. And then now what I have told is, for each and every dynamically created node, I will ask the user, enter the left of its left children of that node and enter the right children of that node. So basically in the first recursion call, I have created a node with data 1. Okay, so then I will ask the user, I will ask the user, enter the left children of that is 1, x is 1. So here I have again called a function, and whatever the function is called, whatever the function returns, see, whatever the function returns, it will be stored in the new node to left field. So from this field I have again called the function here, and again I will call the ask the user, enter the left children. Again I will ask the user, enter the node data. So whenever I have again created a dynamically node, let us suppose I have entered a data here 2, so I will store here 2. After that, again I will, for this particular node, I will ask, enter the left child of 2. In the, you doesn't need to confuse like x is previously 1 and now it becomes 2, because whenever the recursion runs, for each and every function call, the separate copies of the variables will be created. So in each function call, the own copy of the function for the x is creating. So here again I will ask, what is the left children of 2? So again I will do a recursive call for here. So here I have done another recursive call. So when I do a recursive call here, again from the left field I have created another node. So let us suppose user have entered -1. So when user have entered -1, it doesn't store in here. So because user have entered -1, what I need to do is, I will simply return null. See, I have simply returned null. So when the null is returned, the null will be stored in this field. Clear? So null is basically stored in this field, and then it goes to this part of this particular recursive call. I will go to this part, enter the right children of x, means 2. So what is the right children of whatever? I will again call a function that from its right field. Let us suppose user doesn't want to have a right children. So again user will enter the data -1, because I have entered in the bracket, enter -1 if you do not want to create a node. So if suppose user enter -1 here, so what will be happens, null is returned to the previous node's parent node to right field. So here null will be stored, and the tree look like this particular one. And then because this complete recursion call is completed, and the address of this node, see here, the address of this new node is returned to the left field of this particular one. So basically, let us suppose the address of this is 100. So its address will be stored in this field. Clear? And then for this particular recursion call, I have taken a left children, and now I will say what, enter the right children. So let me erase it, and now I will ask this line, in this line, enter the right children of 1. So when user enter the right children of 1, I will again call the enter the right children of 1. I will again call the recursive function, and here user will ask for the data. Let us suppose I have entered the 3 here. So for the particular 3, again I will ask, enter the left children of 3. For each and every node we are recursively calling this function, and we are taking left children, right children of each and every node. And let us suppose if the user enters -1, it means that user doesn't want to having any left or right children. In that particular case, we are returning a null, and after a node is successfully created, we are returning the address of that particular node. We are returning the address of that particular node. So here user doesn't want supposed to have a left children of 3, so user will simply enter a -1, and when -1 is entered, so null will be stored in its field. And similarly, if user doesn't, when the right children is asked, and again the function is called, and the user doesn't want to having a right children of this, so user will enter -1, and null will be stored in this field. So this node will becomes a leaf node. So this look like this particular one. Let us suppose it having an address of 200. So in the final of this, when whole the function is completed, basically, Clear? Then whole the function is completed. I'm in the last, I'm returning the address of the new node. This particular node, I'm returning the address of this node. So this address will be stored in the right field, because in this recursion call, I'm calling it from the right of this node. So here is stored, and for this particular node, let me take a highlighter for this, so it is not showing. For this particular node, I have taken both the left and right children, and then what I will do, again this step, I will return the new node. So finally, in this way the recursion works, and the new node means this is the first node address which is returned in the root, and then the root is pointing to the first node of a tree, and a tree look like this particular one. 1, 2 and 3. So let me explain again. So first of all, I have created a node 1 with node with data 1, and then for its left, I again call the create function and again input the data, and then for this, I again call the create function and again input the data, and when user enters -1 means I have simply written a null here, so there is no, basically there is no node corresponding to left of it. And similarly for this its right, I again call the create function and again input the data, and let us suppose user again enters the -1, so null will be stored in this right field, and now the address of this node, the address of this node with data 2 will be stored in its left field, and for this particular one, I will again call the create function for right children, and then for 3 I will again call the function for its left children, and let us suppose user doesn't want to have, so I will enter -1, so it will be storing a null, and in the right I am asking for a, basically doesn't have the right children, so I am asking for -1 and it will store a null here, and then the address of this 3 is stored in the right field of 1. So in the next videos we will be seeing how to traverse these nodes, because we have created a tree, and how we can see this tree is basically created because we have created it, but we need to traverse or reach each and every node of this tree. So in order to reach each and every node of this tree and see how the basically the traverse, how to traverse this tree and see the data we have stored, so we will see in the next video how to traverse this. If you doesn't understand what I have done here, I will clearly recommend you to please recursively do this. You can draw the recursive tree, you can do the recursion, you can simply search for the recursive stack on the internet, and then you can come to this video, and definitely you will understand what I am doing here. So I will see you next video. Till then, bye bye, and make sure you have subscribed our channel and also press the bell icon.